Hello everyone, this is Elisa Baum. I'm Percona's Director of Product Marketing. We'll begin in just a moment, but first I'd like to conduct a bit of housekeeping. Please raise your hand using the hand icon located in the GoToWebinar control panel to let me know if you can hear me. Okay, great. I see a bunch of hands. Thank you very much. Next, during this webinar, you will be on mute, but should you have any questions during the discussion, please go ahead and enter them in the questions field within the control panel. At the end of the webinar, we will take time to answer as many questions as possible. Those that aren't addressed will be answered in a follow-up blog entry on Percona's MySQL Performance blog. In addition, I'll make sure that everybody gets a recording of this webinar as well as links to the slide within 48 hours. I'd like to thank you for attending today's webinar, OpenStack Technologies You Should Evaluate in 2015, being presented by Percona CEO Peter Zaitsev. And with that said, I'll turn the floor over to Peter. Go ahead, Peter.
Yes, thanks, Alisa. Do you hear me well?
I do.
Yes, and I have a sound check. Well, good day, morning, evening, or whatever time of day it is to everyone. And today I'll talk about the technologies for your data in 2015. I first started writing that as an open source technologies, but then looking at the list, I thought there is some technologies which are not open source, for example, cloud-based, but which also should be on the list, so I changed the title. If you look at that, in this webinar, we'll look at two things, right? First, I'll briefly go over some big data-related trends, which I'm sure you are all aware, and as well as the technology response to them. Now, the biggest trend we can see is what technology is getting everywhere those days in a lot of different parts of our life. And I will mention a few examples, but this list is nowhere inclusive, right? The idea is what there are a lot more devices which are essentially being connected to the internet and otherwise, and which are producing and sending the data. You probably had heard the term the Internet of Things, which we are seeing there are much more things besides the computers and the smartphones which can be connected to the interface and both producing and consuming data. Many of us have some smart thermostats or cameras or some smart TVs or things like Apple TV at our home. Many of us those days not only have the smartphone, but also may have some wearables like Fitbit or smartwatch or something else, which is again another extra device which produces the data. The smartphones, I think, are very interesting also in other way. First, they make access to internet available to much broader populations, especially among their teenagers. Among certain countries, we can see what their smartphone is actually the leading way to access the internet. And what that also causes people to have is their constant engagement. No more they're limited to those maybe a few hours a day that people spend in front of their computers, but they are constantly engaged, getting their messages and advice from an application on the smartphone, which really increase the amount of interactions we deal. Finally, I would mention what there is a lot of penetration in the old economy. We see a lot of things like smart meters or even some old industries and factories tend to get a lot of data from sensors, store and analyze that for the decisions. So what does all that mean for data? Well, that means first what we are getting lots and lots of data. I don't have exactly the graph in terms of how much the data has been increased recently, but this is a double-digit percentage growth year over year, which is expected to and that trend to expand it to continue. Now, what is interesting is if you look at this data, we can see what this data can be presented through the different kind of data structure. So we see some data which is relational and which is presented very well in relational databases like MySQL, for example. Other data can be very well presented in the as a document or tier. There is other data which can be graphed. We have data which is loosely structured. For example, something like log files, which have some structure to them, like there is maybe a timestamp of every record, but not really, because the message can be relatively unstructured. And we have a lot of data which can be completely unstructured, such as essentially text data, which is also being produced. So besides those different data structure, we have a lot of different requirements in terms of how that data should be stored, right? In some cases, we need the data to be stored at a very low cost because we have lots of data, but we may not access that often. In other cases, we have to have a very high performance storage, which will be expensive, but with quick retrieval speed. We have different needs in terms of processing, right? You can often hear, for example, about the needs of online data processing versus some of analytics which can be taken offline. We have a lot of other different requirements when we deal with our data, which can go in case of availability, security, compliance, and others. So what I want to make a point here is there is a lot of different requirements to the data, as well as different data structures. Now, when we have all this data, it is going to be supported by some sort of a hardware infrastructure, and a hardware and a software infrastructure. That may be in-house, and that's or that may be in a premises. What kind of changes do we observe at this point? Well, the first one is what we see a lot of requirements being a lot more agile in terms of being able to roll out things quickly, and in terms of being able to implement changes to the infrastructure quickly. Those kind of 3 months lead time when you request a service being purchased, racked, and put in the in the data center is not cutting that anymore. Another example or requirement to the infrastructure is what we are looking at simple to use. Many developers want something more easy to use than traditional set of instances which are kind of separate and which are manually controlled. The other is the automated. If you look at any large-scale implementation those days, or even a medium scale, you will see very, very high-level automation. Those days when you could be the sysadmin and DBA, essentially just doing things manually and not using any automation technology, are all but gone. What we also see is, which is connected to all of those and some other trends, is what people are looking some sort of their unification. They would like to see some sort of a unified infrastructure, the tools for managing infrastructure, unified database, maybe as a database of a server which they can scale rather simply. Again, using that a simple keyword, which is a very common requirements. Now, beyond the infrastructure, it is good to talk about their people issues. The first challenge which I hear all the time, both from our customers at Percona or going to any conference, is what there is not enough people. You can constantly see what a lot of companies are hiring the data experts, and they simply can't find enough. And what that means is, of course, what the people who exist out there, they have to support much larger infrastructure than have been before. I have seen a number of cases where you would see essentially one ratio of one MySQL DBA to, let's say, 1,000 MySQL services, right? And maybe a similar ratio from their sysadmin standpoint. This, of course, also with high demands, that means is what this skill is expensive, right? Of course, if you are the DBA or other kind of data expert, that means that is all good for you, right? You are on a market which commands their higher salary and high demand for those cases, and there is probably a good choice of the jobs you can take. At the same time, that is, of course, is a challenge for managers which need to deal with all those set of the challenges when their budgets are not really increasing. And another challenge I would highlight here, which we constantly see people complain, is what I would call is a skill and productivity gap. We see that the difference between the outstanding performers and sometime who is the middle or the maybe worst 25% of performance is tremendous those days. And it's also not just a question about having people how long it takes them to do a job, but it is a question of whether they can do a job, or people with a lower skill level may not be qualified to set up the system so it's secure, and you will get the security incidents as a side effect. Or they may take much longer time to resolve an incident, which can cause be very expensively. Or on the first case, the fact we don't have those skills may have caused the incident on the first place. So anyway, that is some of the introduction from the landscape of the challenges. Let's see from a technology standpoint, what kind of technology exists out there in our space, and how is it helping? One term you probably have heard is called the Polyglot Persistence. And what that means is the very simple answer to the first part of the problem. Saying, hey, well, there are a lot of different technologies out there, a lot of different needs, and we can use multiple technologies together. Let us use MySQL for one thing, Hadoop for another, MongoDB for third, and so on and so forth. And this is a good approach, but as every approach, it has its downside, which is increasing complexity. Our approach typically is to recognize and understand what every single new technology you implement and adopt is increasing complexity and in cost. You'll have to have more the people on your team, or you have to have them more trained and familiar with larger set of technologies, and the supporting a lot of them is hard. The interesting example I have from my practice, which is a kind of a bad way of using Polyglot Persistent, is one customers I visited, and they told me, hey, you know what, we heard what Cassandra is very good at handling writes, which is correct. So they went ahead and implement the Cassandra for their login application. Now, I would, because it will be more efficient than MySQL in doing that, which is of course correct as well. But then I would ask them to say, well, how much log records are you guys actually having? Well, it was a 50,000 a day with no real plans to increase that dramatically. So what happened in this case is they would roll out this technology which may be indeed better for this use case, but in their case it was so small what these gains was irrelevant. Now what was the most important here is fast forward about 6 months I hit them again and I was asking about them how their Cassandra login is doing, and what they tell me and say, well, you know what, it should be working, but we cannot really retire the data anymore because the only guy who set it up and who knew that, he has left, and nobody else knows how to manage that technology. That is, of course, is really important, and that is risk you have to be constantly aware about. But having said that, if you look at the companies at the large scale, think about the Facebook or Google or Amazon or Twitter, wherever you pick it, they all would use much more than a single database technology. Now in the next part, I wanted to go through the different technologies and see which we see growing right now and continue to do so in 2015, and explain what they may be good about that. Well, of course you guys know we are big of MySQL, and when I say MySQL I mean MySQL, MariaDB, Percona Server, Amazon RDS. That at large is all big big part of a MySQL ecosystem, and this is a very good database system for a lot of OLTP workload. There is it's very commonly used. It's pretty mature those days, and there is a lot of people available out there who know that pretty well. Now, beyond another very well known relational database is PostgreSQL, which I think is very interesting and wonderful in its difference from MySQL. It has first thing it has is a different license, which is BSD, which makes it usable easily in some sort of environments like embedded applications where you don't have to go through potential license complexity. That also what made it preference of number of government choices, like in places like Brazil, their BSD obviously makes it more open for different kind of use cases internally than GPL. PostgreSQL also has traditionally a lot of interest and features compared to MySQL in terms of a more advanced query optimizer, and one of the interesting things in terms of relational and non-relational data interaction, what I like, PostgreSQL recently got ability to have indexed JSON data, unlike MySQL or MariaDB, where you can actually store both non-SQL and SQL data in PostgreSQL, non-relational and document-based JSON data in PostgreSQL and have it indexed. Another relational database I wanted to cover, which I think is not even considered by a lot of people those days, is SQLite. And indeed, it's not a database which is designed to go and build the next Facebook or the Instagram. But this is a database which is getting very strong in the Internet of Things environment, where it is also licensed very liberally, and it is very small to be embedded in the devices to store the data. This is where a database which is actually is in essentially every smartphone smartphone out there. And from my standpoint, I was always surprised how many features and how good performance for this small single-user environments the team has been able to pack in the SQLite. What we see in our case as a use case is using SQLite maybe as a local database or database cache in client part of the application. Now, another relational but different relational database I want to cover is Vertica. And this is one of those non-open source technologies which I know is very popular, let's say, in a MySQL ecosystem. Why? Well, because this is a very efficient column store database, and there is really not very good and mature column store, open source column store MySQL. Column store database at this point. If you are dealing with relational data structure and you're looking for analytics using the SQL interface, that is one of the technologies I would be looking at. The next one I would mention is MongoDB, which of course you have heard it. And we see a lot of people using MongoDB alongside with MySQL, as well as using MongoDB to build some of a new application. Because I think MongoDB is really great in its simplicity for developers. A lot of developers in the new generation, they understand JavaScript and they understand JSON. They don't necessarily understand SQL, so just getting the JSON objects and JSON-based queries on them later on really allows them to be more productive, and that makes MongoDB a good choice for a number of applications. If I would look at a couple of document-based data engines, I would also flag CouchBase, which seems to be getting a lot of traction last year, and which seems to have some interesting features. What I think is unique about the CouchBase is what it has a different data model where you can use it as a document store as well as a cache, instead of memcache, for example, or as a key value store. All using the same data stack. The next one is the Cassandra, which I think is a very interesting technology from a few things. First, it's really designed to be very well dynamically scalable, self-healing. It provides us a little bit different data consistent model with eventual consistency, and it also can be integrated with MapReduce for large-scale data processing. So especially in the cases where applications are more write-heavy than read, we see people being rather successful with Cassandra too. The next technology I want to mention is Hadoop. And what is interesting for me, what unlike MongoDB or MySQL or even Cassandra, the Hadoop is really this kind of is a massive ecosystem. Their Hadoop is only one part of that. We have technologies like HBase, which is essentially big table-like interface, right, for real-time access to this big data. We have things like Hive and Impala, which provide SQL or SQL-like interface to Hadoop. Those are all the really the different, substantially different products with a lot of technology built specifically for them, but they're all part of this Hadoop ecosystem, and that is what makes me very excited about Hadoop, because unlike the single database technology, it produces more tools for different needs in terms of the data store and processing. The next thing to mention is an Elasticsearch, which has been growing, I think, very aggressively over last couple of years. What is nice with Elasticsearch, I think, compared to some other technologies which existed before it, like Lucene or Solar, is what they got the package together, which is called the ELK stack, which included Elasticsearch, Logstars, and Kibana, which provides you both this engine of Elasticsearch to actually execute full tick search and similar kind of queries, as well as Logstash, which provides you ability to import a lot of data in the system, as well as Kibana to as a tool to create the dashboards and visualize data very well. So we see a lot of people using Elasticsearch very successfully for these kind of applications, full text search, log analysis, and we also have a small installation of Elasticsearch in Kibana at Percona as well. Now let's talk about a couple of special databases. One is Neo4j. This is what I would see as a special purpose database, which works very well if you need to work with graphs. There are ways to work with graphs in SQL language, for example, but these require you, if you write pretty complex, complicated sorts procedures, so you would have to have a very nasty joins, right? So, this system is specifically designed for you to be able to operate on the graphs. For example, think about the social graph, which a lot of our systems are built around. I won't switch back on the slides, but I completely forgot one of the very important requirements which you see in a lot of applications, which is the geolocation. Right? We spoke about the smartphone which we carry, and what we really expect is a lot of functionality in this case, which is provided for us based on our location. And this is where a lot of developments have been done in a number of those technologies. I would say this is something GIS which has been very, very strong in PostgreSQL for years. I think PostgreSQL is significantly ahead of MySQL here, even though there are some improvements coming in MySQL 5.7, as I know. The MongoDB is another technology which really invested in making GIS very easy to use, and I know there is a lot of successful applications with geolocation which is built around MongoDB. So the next technology, and that is the last of the database technologies I want to mention, is Redis. Redis is probably the smallest of all of those technologies in terms of a line of code it takes to implement that. That is relatively basic. It's more complicated than Memcache, but it's rather simple compared to other technologies, but it is very high performance and very powerful. What is interesting about Redis, in my opinion, is what, unlike many other technologies which provides you with single data structure, like relational table or key value or document of a specific structure, the Redis provides you the number of a different data structure, same as we see in the programming languages. We have a hash table, we have a list, we have a like a ring buffer. Redis provides you ability to work with the data in various ways, which is really convenient for and easily understand by a lot of developers. We see Redis used very commonly alongside with different other technologies like MySQL or Postgres or even Mongo, where you can store in memory some of the very hot data which can be modified very quickly and queried very quickly. This is a wonderful kind of supplemental technology to explore for a lot of applications. So the next important development in the technology is the cloud. which we all understand cloud is increasingly used for more and more development. And that is not only about the public cloud, such as Amazon or Rackspace, right, or HP, where is cloud is provided by any large hosting provider, but as well as inside what is called the private cloud, because their cloud is exactly that technology which helps us to automate things and make them more agile and more simple. It makes them much more easily for development to request the database instance, right, without going through a complicated process of getting the Linux server and the installation and so on and so forth. When we look at the cloud, we see Amazon as truly being their leader in the space, at least in US market. There huge amount of very large-scale deployments are being done on Amazon web services, and they provide the tools to both deploy their just simple virtual bulk systems, right, on which you can run any database of your choice, as well as database as a service technologies and many of other solutions for data analysis, such as Redshift for storing the files as S3 and so on and so forth. The next technology to watch a lot is the OpenStack. Right, the Amazon, I think, is a wonderful, but at the same time, going with Amazon, that means there is some, you have some sort of vendor lock-in, and it's Amazon doesn't provide the version of their system which you can run in-house. Right, that means what you either have to go with some other vendors which provide Amazon compatible implementation, right, or you have to use something else. And this is what's so exciting about the OpenStack, being their open source product, and not only open source but also multi-vendor product. It allows you to run the both the same kind of stack both inside of your own data center as well as in the public cloud if you choose. OpenStack is not as mature yet as Amazon Web Services, but we see that growing very rapidly, and probably almost like if you speak about the large companies, like almost every companies I talk to, they have either some test OpenStack installation already, or they have significant plans with OpenStack deployments. Now, the other thing what we mentioned, we should mention the cloud, is the rise of what is called database as a service, which is their idea, which goes again towards their the simplicity piece, is how can we provide something more simple than just giving you the sort of virtual box with some virtual hard drives and so on and so forth, where you would install your favorite database system, right, and configure that and use it. Database as a service supposed to take all of that and reduce the need of a DBAs. And solutions for that are such as Amazon RDS, which exists for MySQL, Oracle, and some other systems. OpenStack Trove, which is essentially the similar functionality for OpenStack. And I would also mention the Amazon Aurora, which was announced a few months ago, which is the database as a service for MySQL, but unlike Amazon RDS for MySQL, it's supposed to be dynamically scalable, more higher performance, and more robust. We're still to see the GA version of that to really check it out. One thing I want to mention about the database as a service, you should manage your expectations carefully. Database as a service, they may reduce need for DBAs, especially DBAs to do some grunt work like install MySQL, configure that, and so on and so forth. But they don't eliminate the role of DBAs as a database architect to think about the strategy. None of the database as a service systems will design the database for you or your queries. You still, to be successful, need those kind of skills are available. Another aspect of a cloud is platform as a service. There is a lot of them. I checked on Wikipedia a couple of days ago. I think there was more than 20 pretty well known ones. These are something which I hear quite often: Cloud Foundry, Google App Engine, Heroku, OpenShift. And what platform as a service is, this is something which goes beyond your normal just delivery of the infrastructure or database, but it allows you to deploy the whole applications together. It includes the orchestration components to that and so on, which can be quite handy. And we would see more and more people looking towards building an application based on that platform as a service for their ease of development in the cloud. Now, we spoke earlier about the large number of people, large number of systems people have to manage those days, and that comes through automation, which is an absolute requirement, because there is no way you can really manage tens, hundreds, thousands of servers successfully unless you invest very heavy in automation. Now, there are a lot of different ways of automation as orchestrations, and there is a lot of tools. I will mention the relatively simple open source tools, which we often see as a cornerstone as an automation which is built, and they are Chef, Puppet, and Ansible. Now, if you look at that, this is, in my opinion, is essentially the case where you can pick any of those free tools for a lot of the tasks, and in a lot of cases we see what the team seems to be taking decisions based on what operational experience people have. There are some subtle difference in terms of what kind of concepts of your systems we have, how recipes are structured, right, and how does this kind of what is the concept, right, of what exactly system tries to automate. But this is something what you often have to check out yourself to see what works best for you. Another technology which is very similar to automation but not exactly is Docker and all those ideas about the containers. Well, why do I see the automation similar to containers to some extent? Because if you, I believe what they play together very, very well. Their containers together with automation allows you to build those containers, and even if you kind of just build containers semi-manually, then you can deploy many instances of that container in your environment. Now, additionally to those tools in automation and OpenStack, we see a lot of interest for extra tools which can allow us to get more insights into the performance of the systems, for example, and to simplify management tasks such as backups or the provisioning and so on and so forth. And especially for some smaller installations, we are people looking for something more more simple than the command line interface a lot of those tools provide. So what I will just mention a few of such interfaces. One is the NewRelic. We see the NewRelic being a very common tool for what is called the application performance management, which is a great tool for high-level understanding how your application performs, why it performs, or doesn't. Again, this is another which is a non-open source tool, but these have been used very successfully by a lot of very agile, modern, and successful companies. Another company I want to mention, or a product, which is by the smaller companies, and it's not that common as they're commonly used as a NewRelic, but it's SeveralNines ClusterControl. This is also a solution which we at Percona has chosen to package with our cluster support for Percona XDB cluster, because it provides a great functionality for it provides in one package the most common needs with functionality such as basic provisioning tools, basic monitoring, backups, and it works both in and out of the cloud. So if you, and I mentioned what we use that for Percona XDB cluster, but in fact this tool works with MongoDB and normal MySQL application as well as Percona XDB cluster. Now, what is close to home in the MySQL space, we see the MySQL Enterprise also being really appreciated by a lot of MySQL users. Again, providing more insights in what is happening without you need to resolve to a lot of command line tools which are often available in open source environment. Another tool what we can see is what we are working at Percona. It's called Percona Cloud Tools. This is now working only with MySQL, Percona Server, MariaDB, just MySQL ecosystem, and it is not really reached its full glory. It's kind of in active development, and it is better in beta, but it already can provide you a lot of great insights in terms of your query performance as well as various metrics. If you look at the MySQL space, I think that's a tool which captures the and makes it available the largest amount of information and metrics, which really makes it very helpful for some advanced diagnostics. And what is also great about that is what it is free for basic use, so you are welcome to try it out. Now finally, another technology trend I want to talk about is Flash, and it is, I'm even surprised why do I need to talk about Flash, because in my mind Flash has been already mature and affordable for number of years. So it is if you have your online transactional database like MySQL or MongoDB and some others, I mean, you should be running that on a Flash. you may choose between very high performance, expensive flash, like Fusion IO or the SanDisk or Virident, or you can use some less expensive flash, but it is so much better compared to your spinning drives. And still, I constantly run into the people who really suffer and struggle trying to get the decent performance from boxes while keeping their data on the spinning disks. Right, so from my opinion as a DBA, if you ever inherit the system which is still on the spinning disks, and that is your kind of high performance requirement for the OLTP kind of workload, their moving to a flash is one of the first things you can consider. So, as a summary, what we have talked in about the new data changes ahead, as what we are getting there, a lot of data which has to be processed in all different ways. At the same time, we just cannot get as many. Can't really grow a team which deals with that in the same way. There is a lot of technologies advances happening, and I hear from a lot of people it's kind of, hey, well, it is a lot what is going on. There is a lot of options for about everything those days when it comes to the data, both in database management stuff, hardware, the cloud, and so on and so forth, right? And that is where we are happy to help you. We have seen a lot of different environments in our practice. We know what works and what doesn't, and we'll be happy to help you. On this note, I also wanted to give a highlight about the MySQL conference in EXPO 2015, which will take place in April in Santa Clara. We just announced our tutorial and breakouts sessions, and note that the early bird price ends on February 1st. So if you have been planning to talk to your boss about the conference, it's a good thing to do it now to get the best prices, which will keep both of you happy. Thank you, and I'm ready for questions now.
Okay, thanks, Peter. Can you hear me okay?
Yes, I do.
Okay, so everyone, if you have any questions, please go ahead and enter them in the questions field within the control panel. At the moment, we don't have any questions, believe it or not, but we did get a couple about the presentation being available after today. And just to let you all know, yes, I will be getting you a copy of the presentation recording as well as the slides within 48 hours. So take a look, make sure you check your inbox for that. And we'll give people a couple minutes to type in some questions. I also wanted to call your attention to the next webinar, which is on January 28th. And Peter, you'll be back with Tim Callahan from Tokutech to talk about TokuDB and Percona. And that's going to be pretty exciting. Do you have anything you want to say about that?
Well, yes, yeah, I think sure. So on the next webinar, we'll look at the TokuDB, and the idea behind that webinar is kind of to for Tim to go through some architecture decisions which have been taken to TokuDB, and how is that different compared to InnoDB, their most commonly used MySQL storage engine and default one. And I will look into what are practical implications that that has, and for what use cases and application TokuDB can be really a great choice compared to InnoDB.
Okay, great. So we do have some questions that have come in, and one of them is, what would you recommend for logging and reporting?
For what you would recommend for logging and reporting? Well, I think that is exactly a very interesting question, which all depends on what kind of login and what kind of reports, right, you're looking on. And I will just mention three technologies, right? You probably know what there is. This kind of login and creating reports has been one of the things on the large scale for Hadoop Ecosystem, right? And MapReduce, that's one opportunity. Another one is if you're looking for logs, which may be logs from your IT system, then Elasticsearch and ELK stack allows you to get something similar to Splunk built very easily, which is actually another good package system you can use for logs. And their third area where you can look at as well is for some technologies, right? We see logs can be very well loaded into their column store, such as Vertica or the Impala from Hadoop and Analyzer for SQL, the SQL queries, right? So these are kind of the big possibilities I would see.
Go ahead.
Yeah, and I just wanted to mention also that in this case, when it speaks to logs, it's important to very much to understand what kind of analysis you are planning to do, because in some cases you get this kind of connections between logs and some BI tools, right? Let's say if by log we're meaning something like a record of all the purchases, right, then that's kind of spills over to some BI tools like Pentaho, which can connect to and work to give you multiple data sources, both Hadoop, MySQL, and others.
Okay. The next question is, the person's thanking you for the overview of a database as a service in PaaS. He'd like to know where he can get more details about database as a service for MySQL.
Well, where would you like to get more details about the database as a service for MySQL? I think in this case, I'm not sure if we as a Percona has wrote any overview about that, but I'm sure if you to check on if you Google, there is going to be a good overview of services for MySQL. And if you look at the overview, I think a lot of providers do that now, right? Amazon RDS is the basically biggest one. Google Cloud SQL, that's also is quite fancy. And what is good about that, they also have now Percona X3B cluster available out there, which you can deploy and get that in their environment. There is HP Cloud has MySQL as a service. So does the Rackspace Cloud, right? So if you to think about that, there is a the broad availability.
Okay. Next question. I wanted to see if you have used Silk at all as a replacement for ELK. I hope that makes sense.
Yes, yes. Well, that's right. That is I have heard of this technology used, right? I honestly haven't seen it yet as commonly used as an ELK, right? And I think that is a really good point, right? I don't think what this technology list should be seen as an as exclusive, right? I mean, if you look at the list of let's say just NoSQL systems, there are more than 100 of them those days, right? We list on Wikipedia, and majority of them have some good reason of existence. What I wanted to go through is relatively mature systems which we see very, very commonly those days, right? And that is where this list came from.
Okay. Next question. Can you please give a high-level comparison of Percona Server, MariaDB, and MySQL. What is the direction each is taking?
Okay, that is a loaded question. But if you look at that, I see that that as follows, right? And in my opinion, Oracle is doing a very job making MySQL better MySQL. And what I mean by that is the MySQL has its kind of niches, this OLTP system, which is relatively simple, simple and lightweight, and it is really getting it's better. It's not trying to go too far in very kind of complicated and advanced enterprise features, right? Which a lot of current users of MySQL probably don't need, right? And I think there have been a very good momentum going out there, and I'm very excited about number of changes which are coming up with the MySQL. MySQL 5.7. Now, if you look about the MariaDB, they are taking a little bit different approach in terms of what features they are focusing on. But I think it's important to understand what, in terms of future technology, MariaDB is likely to be very, very different from MySQL, because you cannot be sort of same and different at the same time. And I think we're doing good in this case by calling itself MariaDB 10, so there is no expectations about what it compares to any of their MySQL versions out there. What MariaDB has been investing a lot in the replication of, as well as some of the things like integration with NoSQL and SQL levels. MariaDB is also vastly focused on the community, getting as many of community contributions in, including storage engines. In this regard, they have much more stuff out there which may not be as mature, and you can actually see that from the recent release what MariaDB provides now, the MariaDB Enterprise, which does not include all the features of a MariaDB, but only includes those which we consider the most stable, right? So there is kind of a little bit different approach to that, right? You may be thinking about MariaDB more like Fedora for the MariaDB Enterprise. And finally, if you look at the Percona server, we are very obsessed with the comparability of Oracle MySQL. We're not trying to be different for the applications. We are focused on the comparability, but we add a few of what I would call a small but high value features. We are focused about the performance, because performance improvements often can be done transparently. Your application just runs faster on Percona server, right, because of our optimizations to InnoDB storage engine. We also focused on the transparency or observability, right, so you can understand a lot more about what's going on with your server with Percona server and our tools than you would see with MySQL. And also what we have done is we have implemented a number of improvements in Percona server which are only available in a commercial version of MySQL, such as thread pool, which is equivalent to MySQL enterprise scalability. We have audit plugin, we have pluggable authentication, which are available in Percona server in a free and open source variant. I hope that answers the question.
Okay, I think that's about all the time we have today. And Peter, there are several more questions. They started coming in. So what I will do is make sure that Peter gets all your questions, and he will address them in a follow-up blog post on MySQL Performance blog. And so with that said, I'd like to thank everybody for attending today's show. I hope you found it informative. And please have a pleasant evening, afternoon, or morning, depending on where you're calling from. And Peter, thank you so much for a great presentation. Take care, everybody.